happen on C when you plug that in? Undefined because why, Angelina? What did we learn about the arguments?
It's not greater than 0.
There you go. Arguments need to be positive, greater than 0. Okay, we already kind of looked at the graph of your logarithms. This part is just, you've already covered it with family of functions. But notice it's going to start at 0, but it's not included 0, okay? It's parentheses 0 to infinity. We have a vertical asymptote at 0 because we derived this from an exponential, which had a horizontal asymptote at 0, and when we switched the x and the y's, then it made it so we had a horizontal here, a vertical there. So anyway, we already kind of looked at that. There's the key features. You guys have done this before. Hey, let's do some practice here, though. If you were to graph this, I'm not going to ask you to graph this, but I want you to just tell me what the transformations are. So here are 4 logarithms with 4 different transformations. What's going on those? Turn to your neighbor, give you about a minute or so to discuss with each, and then I'll call them forward here. Okay, let's do this quick. On A, guys, what's happening? It's going which way? To the left. 2. Good job. I'm going to skip B. Let's go to C. What do we call this 3 if it's out front? What are we doing here? Vertical stretch by 3, right? If it's on the outside, you just do what it tells you. Hey, what about on D? Just up 1. Does it matter if you add before or after the function? Nope. If you're adding, it's going to be up 1. Okay, now B is a little bit tricky. This was on your quiz. What do I have to do here? Go ahead, Kimberly. So it's negative x plus 3, yep. Oh, wait, that's not what I meant to do. Take out the negative, so then it's x minus 3, right? Great. So that's what I have to do there. So what does the negative on the inside do? Flip y. Good. And then what does the plus 3 or the minus 3 on the inside do? Right 3. Good job. Now I included the graphs of these. So let's actually go to the next. I'm going to go to this next page so we can compare that. Okay. So here's the equations on A. This is your parent function, and then I shifted left 2. Is that what we said? Yes. On B, we did 2 things. We flipped it over y, and then we moved it right 3, because it was right here, and then 1, 2, 3. Does that look good? C, we're taking our parent function, and we're stretching it by 3. And then on D, we just shifted it up. Cool. You guys are solid. Okay. Let me do a story problem, and then we're done. Okay. So let me tell you, oh no, I'll use that as our warm-up next time. Okay, never mind. We're just going to do this one. So how do we measure sound? The loudness of sound. What is their unit? Good job. Did you read it?
Yeah.
Oh, okay. But you guys have heard of it before, right? The level of sound intensity in decibels is given by that thing, okay? Where B beta is the number of decibels, I is the sound intensity in, I don't know what that W per meter squared is. And I sub naught is that. Okay, now, this is the threshold of human hearing. In other words, it's the quietest audible sound intensity. So what I want you guys to do is just be super quiet for a second. Good job. What do you hear? The what? I hear the AC going. I want you to think, what is the quietest sound someone could make that you could hear? So, for example, could you hear the jingling right there? Can you, if you hear this, just tap your fingers. Can you hear that? Anyway, I sub 0 is referring to the quietest sound something could make, and you could hear it. You'd be like, oh, I heard that. But it's just so small you can barely hear it. So what they do is they're going to take I, which is going to be the sound intensity, and they divide it by I sub 0, which is 10 to the negative 12. And then they do use logarithms, and basically that helps you figure out how loud something is in decibels, okay? Now, does anyone know why it's called decibels? It's Bell, after Alexander Graham Bell. Which, where did he come from? Oh, yes, but why is he famous? The phone, right? Good job, you guys are good. Okay. So what we're going to do, guys, is we're going to, convert these. This just gives us intensity. We want to convert it into decibels and say, okay, well, so if someone's just whispering, how many decibels is that? If we're outside and we have cars going past, how many decibels is that? At what point do we start getting ow, that hurts my ears, okay? And all we do is we plug it into this formula, okay? So, for example, let's do a soft whisper, okay? So I'm going to do, for the soft whisper, beta is equal to 10. What kind of log is this, guys? If it doesn't have a base, it's a common log, which is base 10. Now, what we're going to do is we're going to do I, which comes from here, and divide it by I sub naught. So what I'm going to have here is I'm going to have 10 to the negative 11 over 10 to the negative 12. Now, I'm definitely going to need a calculator on this one. So let's just go 10 common log, 10 raised to the negative 11 divided by 10 raised to the negative 12. Oh, I actually didn't need a calculator on this one. What does that become? Who's got it? What did you get? Did you get 10, Kimberly? 10. So it's... Alright. Now what I want you guys to do is I want you to figure out the subway train. What is the sound, how many decibels would this subway train be if its intensity was 10 to the negative 2? So do the same thing we just did, but now you're doing it for 10 to the negative 2, not 10 to the negative 1. There's one more. Okay, what did you guys get for the subway train? How many decibels is that? You got this one was 10. Shout it out. Did you guys get it? 100? All right. So this is just an example of where you could see the formula for logarithms in kind of a relatable setting. All right, so good job today. Just as a review, what is a log with base e? Natural log. What is a log with base 10? Remember, if you're converting from an exponential to a log, it's all about that base. And from a log to an exponential, what do we use? Circle of life. Okay, I gave you your homework assignment. It's all tied on one page. Just do it on a separate page. Don't try to cram it in on there. And you only need to do the numbers on top. You don't have to do all of them unless you want some extra practice, okay? Alright, thanks guys. You're awesome. I will see you on Thursday. If you need help, come before after school, alright?